The low voltage would be more like the 48 volt nominal system, right?
Correct.
When we talk about a high voltage battery, what kind of voltage are we talking about?
Now we can get that three-phase 120/208 AC output with just one single inverter instead of having to use three inverters.
Tell us, how does the BMS work for the high voltage solution, and what are some of the additional features that the audience should be aware of?
The smarter way to go solar.
Hi everyone, Joe Ordia here for Solar Surge, and today we're coming to you from RE+, which is the International Solar Conference here in Anaheim, California. And this afternoon I'm joined by Logan Bacher, product manager at Pytes, and we're going to be looking at the new Pytes High Voltage Battery. So Logan, good to see you again.
Thank you.
Tell us about the new high voltage system.
Of course, yes. So this is our new high voltage battery, our HV48100. We're really excited about this product. We've gotten a lot of interest about it so far, only about halfway through day one at the show, so can't wait to tell you a little bit more about it.
Great. Now when we talk about high voltage batteries, or typically batteries we're talking about low voltage or high voltage, the low voltage would be more like the 48 volt nominal system, right?
Correct.
When we talk about a high voltage battery, what kind of voltage are we talking about?
Yeah, so this differs quite a bit from the 48 volt nominal solutions most of us are already familiar with, where we just parallel batteries at that same nominal voltage until we reach our desired capacity. This is a bit different. So now instead of parallel connecting batteries to maintain that 51.2 volts or 48 volt nominal DC input, we're now series connecting the batteries instead. So this is going to get us into a voltage range, in this case, between 200 and 900 volts DC.
And you achieve that by series connecting individual battery modules.
Correct. Yeah.
So yeah, can we take a look inside, see how the batteries are interconnected?
Yeah. We'll take a look inside. So here we are. These are the battery modules, and then the top unit is our control unit. So right away, it looks very similar to our existing V5 battery, and the modules themselves are actually constructed in a very similar manner. So each one of these blocks, each one of these modules is a 48 volt nominal or 51.2 volt battery with 100 amp hours of capacity. So in other words, each block here, each module is a 5 kilowatt hour battery. The difference, as I said earlier, is instead of doing parallel connections, maintaining the whole system voltage at 48, we're now doing series connections. So we can see here moving down the stack, positive to negative, and again, that gets us upwards of 200 volts all the way up into the high 800 volt DC range.
Right. So I'm just looking at the stack here now with what looks like 8 battery modules at roughly 50 volts apiece.
Correct.
So we're looking at just over 400 volts DC with this series connected stack. Now tell us about what are some of the applications where we would use a battery wired in this configuration? What type of inverters or what type of applications will we see this?
Yeah. So again, this will be only compatible with high voltage DC inverters. Models like the Solarc 30K, Solarc 60K, the Solus S6 series, anything with the high voltage DC input. Those are the two inverter brands which at the moment we have UL 9540 certification with. That has been approved for the Solarc 30K, Solus S6 line of inverters. Certification with the Solarc 60K is coming in the next few weeks, but in terms of what kind of an application would you find this being used in, this is kind of getting into the maybe small scale industrial kind of commercial space. So an example with the Solarc 30K, let's say, where maybe the need for power output for kilowatts isn't all that high, but you do need a three-phase 120/208 AC output. So in that case, you can use our high voltage solution, a cabinet, for example, with anywhere from 6 to 8 modules connected in series. That pairs perfectly with the Solarc 30K, and now we can get that three-phase 120/208 AC output with just one single inverter instead of having to use 3 inverters like you would with their 12K or 15K models, the low voltage models.
Makes sense. Now, do you offer this as a complete integrated solution with the enclosure, or does the owner have to piece together however many modules they want?
I would say a little bit of both. So we provide the cabinet, we provide the BMUs, those are the battery module units, that's what actually stores our energy. And then the top piece on here is the BCU, that's our battery control unit. So everything comes from Pytes. This here we see is a fully populated cabinet with 8 modules. So that would be right in the neighborhood of about 40 kilowatt hours of storage in this cabinet here. What we can do, for example, with an inverter such as a Solarc 30K, I'll just use that example. You can have up to 6 cabinets of 8 modules connected to a single inverter, and then you can have that many batteries per each inverter in the system. I think scalability with Solarc 30K, you can do up to 10 inverters in a system. So when we have a fully populated cabinet such as this, again, there's 8 battery modules here connected in series. So that gives us about 40 kilowatt hours of total energy storage. Now you could have up to 6 clusters, as we call them, or cabinets of 8 modules. That's 48 total batteries, which is about 200, close to 250 kilowatt hours. Now you can have that 250 kilowatt hours, 48 battery modules per each inverter in the system. So for something like the Solarc 30K, where we can do 10 inverters together working in a common system, right? You've got 48 batteries per each inverter, so that gets you into almost 250 megawatt hour range of capacity. So by far our most scalable, highest energy storage solution that we've released to date.
Great. Yes, it sounds like highly scalable. Yeah, and then again, the nice thing about the high voltage DC, for those of you who've been following the channel for a while, solar panels typically are going to be wired at high voltage as well. So you might have the solar array wired at 300 to 500 volts.
Right.
If you can take that high voltage, bring it down to ground level, and do your battery charging that way, it's going to be a more efficient high voltage DC to DC charging than always having to step the voltage up and down, because there's always a little bit of conversion loss whenever you do that.
Yeah, great point. Yeah, that's one of the benefits of high voltage. You've got your PV, your battery DC, even your AC output is all running at a much more similar range. So those conversion losses are mitigated quite a bit.
Yeah, and of course you can install using smaller wire size, which is going to save on material costs for the installer.
For sure, yeah. Also gives you the opportunity to place the battery cabinet significantly further from the inverter than you would with a 48 volt nominal system.
Great. So Logan, when is this solution going to be available? Is this something that's for sale now or something coming in the near future?
It is for sale now. We do have, as I said, the 9540 UL certification approved with Solarc and Solus. 30K Solarc is done, 60K is coming soon. So these are available to order. We are, I think, waiting for our next shipment to arrive. I believe everything was purchased already before it landed in the US. So lots of interest on the new high voltage solution, as I said.
So Logan, I understand that there's some changes in the battery management system for the high voltage system versus the V5 that we looked at earlier this year. Tell us, how does the BMS work for the high voltage solution, and what are some of the additional features that the audience should be aware of?
Yeah. So, again, at Pytes, we always try to innovate. One of the driving forces, I think, behind our research and development and product development is feedback from customers and installers in the field. So we listen to you, we hear your complaints and headaches, and we try to make each product a little bit better than the next. So that being said, in this high voltage model, we've moved away from a MOSFET-based BMS to a contactor-based BMS, which is a little bit more robust, a little bit safer in general too. You now have that physical disconnection between the control unit and the rest of the battery modules. This installer contactor switch here will physically disconnect both the positive and negative poles on the battery unit. That being said, since this is a contactor-based BMS, we can now also do a remote shutdown of the system as well. And then this model now has a pre-charge circuit incorporated, so hoping to avoid potential damage or BMS board issues when we're starting up an inverter for the first time.
Makes sense. Okay. Well, Logan, anything else the audience should know about the high voltage solution?
I think maybe just a quick rundown of sort of the architecture of how this is put together. As I said, it looks really similar to our V5. We're just doing series connections, not parallel. The top unit is our battery control unit. So this is kind of the brains of the entire system, right? This is the guy that's running the show. This is what the user, the installer is interacting with. This is what's communicating with our inverter. Now each battery module still has its own individual BMS. So we've got, full protection for each component that's included in the cabinet.
Great, great. Well, folks, this has been an introduction to the Pytes High Voltage DC battery solution. Again, folks, the reason when we come to these shows like RE Plus is we want to make sure that you're staying up to date with all the best solar battery technology and product information. So if you haven't subscribed to the channel already, make sure you hit that subscribe button. That way, as we have these new videos coming out from the show, it'll come up on your feed so you can stay up to date and you won't miss anything. Well, Logan, I appreciate you taking some more time to chat with us this afternoon.
Thanks for having us.
But folks, that does it for today's video. Thanks for spending some more time on the Solar Surge channel. And as always, I'm Joe Ordia, encouraging you to get prepared and be empowered. Thanks for watching, and we'll see you on the next video.